Okay, so today we're looking at binary, and it can be confusing because it's just zeros and ones. But everything in the computer is stored as those zeros and ones, whether it be a picture, or it be a bit of sound, or a program. Everything gets stored as zeros and ones. And essentially all it means is on or off, because the currency of the computer is electricity, and it stores that electricity in a charged state or an uncharged state. So, part of the problem is you're taught in denary. And that's useful for us because we've got like 10 digits, we can count really, really fast in tens, that works. So if we look at this number 3140, we know it's 3,140. Now this 4 column is worth 4 tens, and we know that, and this is worth 100, and this is at 3,000. But we only know that because we've learned that what those columns are worth, and we work left to left from the left. Same thing in binary. This end column is always worth 1. So if somebody gives you 4 binary numbers, 0, 1, 1, 1, we'd know that this end one is always going to be worth 1. Okay, we aren't going to start at 128. And the numbers double. So 1 to 2, 4, 8, 16, 32, 64, 128. And these 64 and 32, these are like kind of magic numbers that you see quite a lot of the time, with operating systems being 32 and 64-bit. So if you panic in the exam, know you've got to write 8, because 8 bits or 8 zeros and ones is a byte. We're always going to start with a 1 and double. So how do you work this out? How do you convert these zeros and ones into decimal? So we left this chart on the right hand side so you can see where we're going. I've got my 128, 64, 32, 16, 8, 4, 2 and 1 written along the top, so I know what everything's worth. If I've got a 1 in that column, it means I need it. So when I'm writing in the exam, I'll put a 16 plus a 4, because they're the only numbers that are turned on. I'm not writing 128 because there's a 0 in that column, which means I'm not using it. So 16 plus 4 is 20. So if a column has got a 1 in it, that means add that number onto it. So an 8, 4, 2 and 1, add those numbers together. Now you might be able to do that in your head, but it's best to write them down. So 8 plus 4 plus 2 plus 1. There's a little trick with this, that if to the right of the number, if they're all turned on, so in this case 8, 4, 2 and 1 are turned on, I know that's 15. If the 16, 8, 4, 2 and 1 columns are on, I know that's worth 31. And that's not because I've added them lots of times, it's because that 32 column exists because I can't make 32 just using the numbers to the right of it. I can't make 64 with all the numbers to the right of it. So if they're all turned on, it must mean that it's 1 less than the column to the left. So if the 128 was off, 64 was on, 32 was on, 16 was on, 8 was on, 4 was on, 2 was on, 1 was on. I could add those all. I could add them all together. However, I just know it's 127. Converting from decimal to binary. So first of all, you need to know what your placeholders are. So always write them along the top, starting on the left hand side. 128, 64, 32, 16, 8, 4, 2 and 1. So the number we're going to try and make is 12. Now this is a hard number because we can't make it by just turning on one of the columns. We're going to have to combine some columns together. So 128 is too many, so we stick a 0 in that column. 64 is too many, so we stick a 0 in there. 32 the same. 16 too many. 8, yeah, well, that's less than 12. So now we've updated our number. We're only 4 away. So 4, put a 1 in the 4 column, a 0 in the 2 column, and a 0 in the 1 column. Because adding 8 and 4 together would give us 12. So if we want to use that column, we put a 1. If we don't want it, we put a 0. Let's try again. Say the number was 34. 128 would be too many, so a 0 would go in the 128 column, a 0 would go in the 64 column, 32, we'll take that. Now we're only 2 away. So if we're only 2 away, 16 is too many, 8 is too many, 4 is too many, 2 we need, and then 4 we don't need anything else. 32 plus 2 would give us 34, and that's how we'd write the answer in the exam. So binary to hexadecimal. You don't really need to know what the binary is worth. They'll just give you a string of binary zeros and ones. So let's just write them in here. Let's say we're using 0, 0, 0, 1, 0, 1, 0, and we'll throw 1 in. Okay, now I can add that up, and I can see that that is actually 21, but it doesn't matter. First thing we do is we split the byte in half into 2 nibbles. Two lots of 4 bits, sorry. So rewrite the values so that now it's a nibble. So it's 1, 2, 4, and 8. That's what they're worth. Because the first 4 columns are worth 1, 2, 4, and 8. So we do it on both sides. So this one stays the same. 4 plus 1 gives us 5. Now before, that 1 was worth 16, but now it's just worth 1 because it's a nibble, not part of the byte. And then we just write them below, directly below. So 1 in hexadecimal is 1, and 5 in hexadecimal is 5. So there we've converted from binary to hexadecimal. Let's try it with some numbers that look a bit more random. Okay, first of all, write your binary string in straight away. Just write it in. There could be any numbers you want, but in the exam they're probably going to give you a binary string and say convert this to hexadecimal. So we'll have no 28s, no 64s, a 32, an 8, a 2, and a 0. Okay? So we need to convert that binary string into hexadecimal. Split it in half, write the values again, 1, 2, 4, and 8. Now what are they worth? What are these nibbles worth? 8 plus 2 is 10. And what's not a 32 anymore, it's just a 2. So we just write the 2 there. So 2 in hexadecimal is written as a 2. However, 10 is not written as 10, it's written as an A. The key here is having this chart on the right. Now you can make this in the exam, just literally go from 0 to 15 in decimal, then put hexadecimal 0 through to F, and then do your binary along the side of it. It's going to take a bit of time to write out, but it will save you a long time because you can just check it in the end. So the other thing they can ask you to do is a decimal number to hexadecimal. So what is the hexadecimal for 15? What's the hexadecimal for 71? So we're going to look at the hexadecimal value for decimal 31. So first of all, we can't do this in my head, so we have to write it out. 1, 2, 4, 8, 16, 32, 64, and 128. We've got our values along the top. So work out what the binary is first of all. So what's the binary for 31? This is where we combine all the skills we've learned so far. So that's too many, 16. And like I said before, because it's to the right of 32, we just know it's 1 on each of those. Okay, we'll split it in half directly in the middle, make the byte into a nibble. Use a samurai sword if you want to think of it like that to cut the binary byte in half. So write the values now, 1, 2, 4, and 8. Remember, it's now a nibble. So now what we're going to do is we're going to add these together. So we've got 15 and a 1. So 1 in hexadecimal is written as a 1, and a 15 is written as an F. So that's more of a 3-stage process. You've got to start off with your decimal number, convert that decimal number into binary, and then know how to do binary into hexadecimal. So 1F is 31 in decimal. And that's how we'd answer it.